Hello guys, welcome to Tech Alpha Anju. So till now we learned lot of topics, right? Like machine learning fundamentals, statistics, and now machine learning algorithms. So in machine learning algorithms, we've seen some basic concepts on linear regression and also logistic regression and what is supervised learning. And now we are going to see what is support vector vision. But in this video, we are going to learn logistic regression. It is like a simple regression only. It is used in many algorithms also, and this logistic regression, which is supervised learning algorithm, so it is used for classification tasks. Okay, let me explain simply. Like I'll explain what is the supervised logistic regression, where we are using logistic regression, why we are using logistic regression, where we have to implement logistic regression in coding and all. So I hope you will not be tired on this, and I'll do some mistakes, sorry for that, and I'll try to improve in coming videos. So now we're talking about something like logistic regression, and the logistic regression is one of the most popular classification model which is used in every machine learning concepts. So it is a supervised machine learning algorithm used to predict categorical outputs. So it decepts its name containing regression. It's okay. It has regression. Why? Where regression is a numerical value, which predicts the numerical value. Then why we are calling logistic regression, which predicts the categorical values? Why we can't predict numerical value means where we are using sigmoid function in logistic regression. In coming video, I'll explain about sigmoid function also. So logistic regression is the mainly used for classification problem such as snap detection, disease prediction, fraud detection, and also yes or no, pass or fail. So if we want student to pass or fail means we'll just see what student is studying. Like if we write exam only, he can pass or fail now. We don't know what is the actual predicted outcome, whether he is pass or whether he can fail, but output will come now. So like this, it has the input futures and also predictive futures. Predictive futures means yes or no. We don't know he will pass or fail, but any one output will come now. So this is the predictive future, and this is all about like a logistic regression. I hope you understand this. One second, guys. I hope you understand this definition. And 1 second, I'll just on the video. Yeah. So I shown the video. I shown in this video. Where the logistic regression has definition. Logistic regression is a supervised machine learning algorithm. It is used to predict the categorical outputs. So examples also I given. Unlike linear regression, which predicts numbers, and logistic regression predicts categories. Okay, which linear regression predicts the numbers, and logistic regression which predicts the categories. I hope you understand. So we'll go something. Why do we use logistic regression? Okay. We have many programs, right? Then why we are using logistic regression? Let me explain. So here we use logistic regression when the output belongs to the classes. So when the output belongs to the classes like pass or fail. If a person is there, student is there, he may pass or fail. Something will take like 2 students, they are going to fail. 3 students, they are going to fail. 5 students, they are going to pass. 7 students, they are going to pass. Means like this. Like what we are doing here, we are predicting whether the student will pass or fail. So this is the logistic regression. So now we'll see like logistic regression versus linear regression. So linear regression which predicts the numbers, and logistic regression which predicts the categories, and the output of logistic regression is continuous, and the output for logistic regression is discrete. Linear regression output is continuous, and the output for the logistic regression is like discrete. And for example, we can say house prices. We seen lot of example on it also. And in logistic regression, we can say disease, whether a patient have disease or not, and the salary prediction. And the salary prediction is also one of the example for the linear regression. And disease prediction and SAP detection, whether it is the fake or not, like that, we can also estimate by this using logistic regression. I hope you understand the formula. So in interview answer, they can ask like. What is linear regression? You simply say like linear regression is a supervised learning model, and it predicts the categorical variables. So if you ask what is the difference between linear regression and logistic regression means, you can simply say like linear regression predicts continuous values, and whereas logistic regression predicts the category values. So now we'll say something like I told you now where the sigmoid function came. instead of straight line. So in linear regression, we use straight line, linear formula, y is equal to mx plus c. But instead of that, here we are using sigmoid function. Logistic regression is using sigmoid function. Thus, the sigmoid function is like a p of y is equal to 1 by 1 plus e of z minus z, where z is equal to b of 0 plus b1x means. So means here p of phi. What here doing? P of phi is equal to 1. P of phi is means the probability of output belongs to class 1. The probability of output belongs to class 1 means the output is belong to class 1 now. And here we are taking E. E means it is a Euclidean number. Euclidean number is approximately like 2.718. So Z is linear equation value. So B naught is equal to intercept, which is bias, and B1 is equal to coefficient, which is weight, and X is the input future. So here we are taking input future, and yeah, this one. This is input future. B1 is coefficient, which is weight, and B naught is equal to intercept, which is bias. We all know what is bias. It is overfitting. Underfitting. The model learned too little and also performs too little only. So this is the sigmoid function formula. So we can say like logistic regression first calculates. It will first calculate the linear value. Means it will calculate the z is equal to b naught plus b0 plus b1x. Then it passes this value through the sigmoid function. So after getting the z value, it passes through the sigmoid function, and which converts into probability between 0 and 1. So okay, why we are using sigmoid function? We are just talking about sigmoid function, but why we are using sigmoid function? I told you now, logistic regression which have a regression, but we can't use any numerical value in it. It is why because we are using sigmoid function in logistic regression, so only we are calling regression to the logistic regression. So I hope you understand. Logistic regression which converts predictor value into the probabilities. Probabilities like 0 and 1. I told you now 0.5 is greater than 0.5, less than 0.5. Greater than 0.5 is best fit, less than 0.5 is worst fit. So if the probability is greater than 0.5 predicts the class 1. And if the probability of 0.5 predicts means less than predict means it is go to class 0. So this is the formula for logistic regression. Now we'll talk something like a decision boundary. This is very important. And 1 second guys, I'm just opening this. Yeah. Example, if you give a 50% is 50% above means pass, 50% below means fail. So if you give 50% above means if you get 0.9, 0.8, 0.7 means you will get 1 means pass. You will describe 1 or else and if fails means you describe like fail means 0. If you want to classify gender, female and male, you will give male as 1 and female has 0. It will classify data. If male comments, it will computer will think like okay, he is 1. So we have to understand 1 is male. It will convert that predictive value into probability. So we have to understand by categorical variables, descriptive variables. So here there is a decision boundary. If boundary is greater than or equal to 0.5 means is class 1. If the boundary is less than 0.5 means it is class 2, 0. So we have something like real-time examples. In real-time examples we have some wait guys, something. Yeah. So here we can see what is the real-time examples. So real-time examples which detects the number of links and email length will give some input. Input like we have number of links and email length and suspicious words. So by using that one, we'll get output like it is fake or not. So like this we'll do. And logistic regression which calculates the probability and classifies the email. So here we'll take a iris dataset example. The famous iris dataset contains features like a sepal length, petal length and petal width. And classes it has different types of flowers, right? So in different types only it will contains this 4 different features. So in classes also setosa, versicolor and virginica. So these are the predictor flower species. So it is same like linear regression. So only I'm not doing code. I'm just explaining one line by one line. So just see. So Python code will come like this and so Python code will come like this. Python code from sklearn.datasets. We are loading iris dataset, which is automatically loaded inside the programming. And also from model selection, we are importing test train splitter to divide the test data and also time data. And from the linear model, we are importing logistic regression to perform the action on the program. And from metrics, we are importing accuracy score. We need accuracy score, right? So we are taking accuracy score where we'll took MSC, mean squared error, and R2 score in linear regression. So here we are taking the accuracy score, and first we have to load the data set. First we have to load the iris data set, and then we are giving x value and y value. X is equal to iris data and y is equal to iris target data. So here we are splitting. You are splitting x trained and training data and testing data. So here we are splitting test data for 0.2 means 20%. 20% of data going for testing, and another 80% of data is going for training. So random state we gave in 42, and we need to create model first. How we will create model? By using logistic regression, maximum 200. So we need to train the model. We need to train the model and with the model x train comma y train, and then we need to predict the model. It is a x tester, and then we need to check the accuracy score. So we given the y test and y predict. Predictive values we given, and y tester means 20% of data we given, and predictive value is given. What is the predictive value? If a person passes or fail in exam means passer and fail. This is the predictive values. So we given these two, and here we are printing accuracy score. So if we do this, if you do this code means we'll get something like accuracy like 1.0. 1.0 means 100. It means 100% of data is accurate. So the predictions are correct. Accuracy measures the percentage of correctly classified samples. So this is all about programming code. So you can try your own. We'll get the accuracy score of 1.0, and then we can see something like 1 second. Yeah. So now we are going to see what is the advantages and what is the disadvantages of logistic regression. Advantages, it is easy to understand. It is very easy to understand. It just classifies in the model, right? So it is, and also it is very similar to linear regression only. We need to change only the logistic and linear regression and some of the libraries and all. So otherwise, all the syntax is same. And it is fast training and works well for binary classification. I told you now we use sigmoid function to change predictions into binary format probabilities. So it works well on binary classification and less computation cost. It has a less computational cost, and also it provides the output. So it provides the probability output, means it provides, I told you now, it provides the 0.1 and decision boundaries. So then we can see something like disadvantages. Disadvantages something like it assumes linear relationship. It can't perform linear relationship because that is in numerical values. This is in classification values. So it is not suitable for highly complex data. It is not only suitable for highly complex data, and it is sensitive to outliers. And whether the linear regression also sensitive to outliers, and it has lower performance on non-linear datasets. In non-linear datasets, it has lower performance. So important terms we can see like class and category to predict. Yeah, class and category to predict. So how means, example, we'll take pass or fail. So we'll take pass or fail. The probability, the chance of belonging to class. The chances of belonging to class means 0.95 is equal to 95% of chances of pass. Decision boundary threshold used to separate classes. It is usually 0.5. So it is usually 0.5. So now we are going to see some interview questions, very important. They ask in interview. So they'll ask like, what is regression now? What is regression means? It is a supervised learning model. It is used for classification problems and predicts the probability of the data between the 0 and 1. And why it is called regression? If it is classification means it is called because of we use the probabilities by using the sigmoid function. So final output class will be labeled. What is sigmoid function means? It is a mathematical function which converts the probability into the which converts the predictions values into the probability between 0 and 1. So what is the output of logistic regression? What is the output of logistic regression is probability of 0 and 1. So the difference between linear and logistic regression is very common. Linear is numerical, logistic classification. And what metrics are used? Now we use accuracy metrics, and we can use perception, we can use recall, F1 score, and ROC AUV. We can see this all in coming videos. We can see precision, recall, F1 score, and ROC AUV. So this is all about logistic regression. I hope you will understand. So today we learned logistic regression, a supervised machine learning model, and it is used to classify the tasks. Unlike linear regression, it predicts the category list, such as it predicts the fake or not, and also it predicts the pass or fail, and it predicts the disease there or not, like that. So logistic regression, which uses sigmoid function, and it converts the predict value into the probability values, which is 0 and 1, and because of its simplicity, so it is usually 0.5. So now we are going to see some interview questions, very important. They ask in interview. So they'll ask like, what is regression now? What is regression means? It is a supervised learning model. It is used for classification problems and predicts the probability of the data between the 0 and 1. And why it is called regression? If it is classification means it is called because of using probabilities by using the sigmoid function. So final output class will be labeled. What is sigmoid function means? It is a mathematical function which converts the probability into the which converts the prediction values into the probability between 0 and 1. So what is the output of logistic regression? What is the output of logistic regression is probability of 0 and 1. So the difference between linear and logistic regression is very common. Linear is numerical, logistic classification. And what metrics are used? Now we use accuracy metrics, and we can use perception, we can use recall, F1 score, and ROC AUV. We can see these all in coming videos. We can see precision, recall, F1 score, and ROC AUV. So this is all about logistic regression. I hope you will understand. So today we learned logistic regression, a supervised machine learning model, and it is used to classify the tasks. Unlike linear regression, it predicts the category list, such as it predicts the fake or not, and also it predicts the pass or fail, and it predicts the disease there or not, like that. So logistic regression, which uses sigmoid function, and it converts the predict value into the probability values, which is 0 and 1. And because of its simplicity and speed and interpretability, it is very famous, and it remains one of the most widely used classification algorithm in machine learning. So logistic regression is a supervised machine learning algorithm used for classification models to predict the probabilities of the data point belonging to the particular class. So this is all about linear regression model, and I hope you understand what is the linear regression and what is the logistic regression. Now we are going to see support vector mission. It is also most widely used concept, and it is basically comes for the both linear regression and logistic regression, but mainly used for the classification models. So next we are going to see what is the linear regression, what is the logistic already we finished, right? So next we are going to see what is the support vector mission. Thank you for watching, and I hope you will subscribe my channel, and if I do any mistakes, please comment down and that I can improve. So this is Anjali signing off, Tech Alpha Anju.